Okay, so now we're taking a look at AS2 from June 2009. This has given us again an opportunity to say what is meant by diffraction. And remember, diffraction is the spreading of waves. So it is the spreading of waves, and it's important that it's the spreading of waves. And when does that occur? The spreading of waves through a gap or aperture. That's quite often used there. Through the spread of waves through a gap, and then just to finish that off, you could add into regions of geometric shadow. But again, the minimum that the examiner is looking for is it's the spreading of waves. That's what we mean by diffraction. It's the spreading of waves, and then it's through a gap. Okay, so that is important. It only happens through a gap, or I suppose around obstacles would be acceptable there as well. Right. Next focus then is on this diagram again, and this time when we look at it, what we've got is we have waves which are coming through a wide aperture, a wide gap, a wide opening. So that means that we will get some diffraction, but we will only get diffraction around the edges. Now, in this, there are 3 marks for this, and the examiner is looking for precision, and probably as we've gone along, they're looking for more and more precision in terms of this. So I'm just measuring the wavelength there. Appears to be approximately, well, I suppose it's about, that's at 11, 12, just over 12 millimeters. So I'm going to just produce that further on from there, and just about 12 each time. So 12 from there, 12 from there, and it says drawing 4 wavefronts. So I'm going to draw the 4 wavefronts that are asked for, that's requested. Follow the instructions of the examiner, and then those waves come straight through here without any change. Okay, straight through without any change, straight through, and this is the region of geometric shadow, and then straight through. Now again, what I would say is you should be doing these diagrams with a pencil, and so you're going to be a little bit more able to rub out than I can with this. But now we get a little bit of diffraction at the edges, and what we find is that this must get progressively bigger as we go along, and so then that would be where the marks are going to be obtained. So we're getting marks here for 1, 2, 3, 4 going straight through. The fact that we're getting a little bit of diffraction at the edges, and then the fact that it's getting bigger as it goes along. Okay, so this is progressively bigger. Those are the 3 marks. Alright, final question is just testing our understanding of diffraction and why diffraction occurs. In order for diffraction to occur, we need to see the wavelength approximately equal to the size of the aperture. So light, okay, has a much smaller wavelength compared to sound. So that's the first thing that we note here, that the wavelength of light is much smaller than the wavelength of sound. Quite difficult to answer this just in the amount of space that you're given there, but we'll try. So the diffraction effect is most noticeable when the wavelength is approximately equal to the gap. Now I've run out of room here, so the width of the door equals the wavelength of sound, and so greater diffraction of sound occurs. Now, I'm sure I could maybe have thought about that a wee bit better and just said, you know, the wavelength of sound greater than the wavelength of light. Diffraction is dependent on the wavelength, so the bigger the wavelength, the bigger the gap that's required, the smaller the wavelength, the smaller the gap that's required, and the width of the door has approximately equal to the width of sound, or sorry, the wavelength of sound is approximately equal to the width of the door, and therefore we get diffraction of the sound rather than diffraction of light. But we've got most of the points in there, and I think that we would get our marks for that.